Hello everybody, welcome to the webinar for new full spectrum cytometry QC and data analysis tools in SpectroFlo 2.2 and FCS Express 7. The teams at Cytek and Novo software are really happy that everybody could join us today for this webinar to discuss some of the new functionality in the SpectroFlo software from Cytek and as well as some new functionality in FCS Express 7 from Novo software. My name is Sean Burke from Novo software. I'm also joined on the call today by Janelle Shook from Cytek Biosciences. And again, we're really excited to have this collaboration between Cytek Biosciences and Novo software so we can bring you webinars like this. We have also partnered so we can seamlessly read raw spectral data in FCS Express 7 from Cytek systems. And the collaboration brings the powerful combination of the cutting-edge spectral flow cytometry technologies from Cytek along with advanced data analysis tools in FCS Express. Additionally, Cytek systems purchased after July 6, 2018 are eligible to receive a license of FCS Express 7 with their instrument. And on today's webinar, we're going to be focusing on new tools from both Cytek Biosciences and Novo software that can help optimize your multicolor panels. So during the first half of the webinar, Janelle Shook is going to present new tools in SpectroFlo version 2.2, including similarity indexes, complexity indexes, and much more. Then during the second half of the webinar, I'm going to present some content about new tools in FCS Express 7, including spectrum plots, N-by-N plots, multi-parameter histograms, and a lot of the other new functionality that's available within FCS Express 7. So with that, I'd like to introduce Janelle Shook. We're going to make her the presenter here, and she's going to take over for the first portion on the webinar to tell us a little bit about some of the new tools in SpectroFlo.
Okay, thank you, Sean. Can you hear me okay?
Coming through great. Thanks, Janelle.
All right. And before I jump into all of the great SpectroFlo version 2.2 tools, I'd like to step back and quickly highlight the platform that the data we'll go through today was collected on. So that data, let me get my PowerPoint clicker working here, was generated from a full spectrum cytometer from Cytek. And there's two different product lines for these. There's the Cytek Aurora, which comes with 3, 4, or 5 lasers. And there's also the Northern Lights product line, which can be available with 1, 2, or 3 lasers. The technology behind each of these systems is the same. So let me show you the 5 laser Aurora and show you what the optics configuration looks from that system, as this is the system that the data sets were acquired from for today. So on this system, there's 5 lasers, and they're all spatially separated as they move through our flow cell. And then as your sample passes in front of the lasers, any emitted fluorescence light is captured by the fiber optic cables and routed to dedicated detector modules that have up to 16 APDs inside of them to capture that emitted light across the full spectrum. And inside each of those modules, there's up to 16 different detectors, and there's a filter in front of each one, capturing different wavelengths of light. Now what's great about these detectors is they're very low noise, and they have very high sensitivity and high quantum efficiency. And that means we're going to have really great data coming out of the system when you run your panels on it. What's important on these spectral systems is that you need to know what each control looks like, what each of those fluorescent signatures looks like. To do that on the Aurora, we look at each single detector module, and we generate a pattern. So if you have a dye like this one that is excited by every single laser on board, you'll get some amount of intensity in different detectors on each and every one of these detector modules. And what you're seeing here, if I look at this top plot here off of the UV module, on the bottom I'm looking at each and every detector from lowest wavelength to highest wavelength. And on the y-axis is the intensity, so your median fluorescence for all the events that are seen through each one of those detectors. Once we have these patterns, the software ends up stitching those together to create this full spectrum signature. And this is the fingerprint for this dye on our system. Once you've recorded all of your fluorescence reference controls, the software will then use that information to unmix your multicolor sample and figure out which fluorochromes are present on every cell in your sample and to what quantity. A little closer up view of that full spectrum signature here for you. You can see we've got the 5 different detector modules laid out from left to right, starting with the lowest wavelength laser, going to the highest wavelength at the end. And again, all the detectors are on the x-axis, and the MFI, the intensity of the events in every single detector on board, is shown in the signature. Now when you're running your experiment, the workflow is very similar to what you're used to with a conventional cytometer. You check your instrument settings, and we provide a Cytek assay setting for you to start with, which you really only need to adjust if your signals are off scale for your samples. Then you go ahead and you record all of your single-stained reference controls, and the workflow here is very similar to what you'd be doing if you were generating a compensation matrix on a conventional system. What's unique for our system is we also need you to record an unstained sample control, and that's important so we can capture the autofluorescence contribution from your sample. Once all of your controls are recorded, you're going to go ahead and go through our unmixing wizard, and you'll gate on your positives and on your negatives like what you're used to doing. And once you've completed that, you can start recording your multicolor sample and viewing it in the workspace that you're used to seeing, where you have all of your fluorochromes and markers on the axes, rather than the raw detector channels as you saw prior to unmixing your data. Now that you're a little familiar with the instrument, let's jump into some of the new tools that are available in SpectroFlo 2.2 to help you QC these controls and your panel designs. Here's a list of everything we'll walk through today. We'll start with benchmark controls that you can store in the system and talk through a couple of indices that we've created to help you assess your panel. Then we'll discuss how to choose the best possible controls for your panel and talk about the different tools available in SpectroFlo and in FCS Express to help you evaluate your panel's performance. First, we added this tool. If you're familiar with SpectroFlo, in our unmixing wizard, there's a new tab called QC Controls. And on the left side, there's a spectral profile menu. And what you can see here are all of the controls that the user recorded in the experiment for that day. In the red behind it are what are the stored benchmark controls that an administrator on the system recorded and saved on the system, so that you can compare the control from today to what's already stored on your instrument. And what I'm seeing here is I've got FTSE on this first row, PE in the middle, and APC on the bottom. And the software then automatically compares that control to the stored benchmark. And if it doesn't match well, like this FTSE control here, it will flag it based on this Similarity Index that we've created. Now the Similarity Index will range anywhere from 0 to 1. If it's close to 1, that means there's a really good match between the control you ran today and the stored benchmark in the system. However, if it's closer to 0, like this FTSE control here, that means there is not a very good match. And in this case, the user ran the wrong dye for their FTSE reference control, and they'd want to go back and recreate that tube and rerun it. For the PE and the APC here, however, the overlays match up really well with the benchmark, so the user did a great job of generating those controls. In addition to using the Similarity Index to check that you ran the right control for your experiment, you can also use it to help with your panel design. The more unique the set of dyes are in your panel, the easier they are to use together, as there's going to be less spillover spreading. To give you a couple examples of this, here's one set of dyes that will appear in the data sets today. What you're looking at is a normalized MFI spectrum overlay. We exported the MFI from every single detector on the Aurora for each of these single stain controls. And we normalized the MFI, so now it's on a scale of 0 to 100%. In green, you're seeing per CP E4 710, and in the dotted blue line, you're seeing per CP Psi 5.5. What you can see between these two is they're quite similar in their emission characteristics. It's almost like they're emitting in the exact same places on each laser line, and they're both excited by all 5 lasers on board the system. So when two dyes have such close emission characteristics, you wouldn't be surprised that they have quite a high similarity index score. For this particular combination, it was 0.9. Now compare that to something like this, where I have BUV 395 shown in the gray and APC shown in the dotted red. There's virtually 0 similar emission characteristics between these two dyes' emission spectra across the full spectrum on the Aurora cytometer. Consequently, you'd expect it to have a very low similarity index, and sure enough, these two came out with a similarity index of 0. To see this in the software, in the Unmixing Experiment Wizard, again, it's in the QC Controls menu, but underneath that Spectral Profile option, there's a Similarity Matrix option. Once you go there, you'll see a matrix generated that looks like this, where it has all of your different dyes in your panel, shown on both the side and the top, then you'll see this color coding that helps give you a visual indicator of how similar or not those dye pairs are. So for example, this BV421 and Alexa 448 are colored in white, meaning they have a very low similarity, so they're not like each other at all. Whereas something with a darker pink or a red, like the Super Bright 600 MPE, would have a higher similarity index. If you'd like to see those exact values, you can click this View Similarity Index button, and then the software will overlay each of those similarity indices in this matrix format. Now the one thing you probably noticed is there's an additional index shown here, the complexity index. And what this index is an overall measure of the uniqueness of all the dyes used together in your panel at an aggregate level. So the lower you can get this number, that means the easier the combination of dyes are going to be to work with in your panel. And this can be helpful when you're trying to choose fluorochromes to put with your different markers for your panel design. To give you a couple of reference values for what these numbers can look like, this 10-color panel shown here at the left came out with a complexity index of 2.5. If you were to go to Cytek's website and in the Aurora brochure look at that 35-color panel, the complexity index for that panel is around 48. Today, we generated two different 10-color panels that both use the same markers, but use very different dye choices to help illustrate these indices visually for you. So let's walk through those together. The two panels are shown here. In the table on the left, you can see the different labels that are part of this panel in black, and then the dyes that are conjugated to each of those labels are shown in the columns for panel 1 and for panel 2. I've color-coded them, so any dye that's maximally excited by the UV laser is in pink, and then the other colors are self-explanatory. Then over here on the right, we've got a little hierarchy, just giving you a high-level view of the different markers that are present in this panel. So it's a surface immunophenotyping panel, and we ran it in human whole blood. We can look at granulocytes, monocytes, lymphocytes, and several different subsets off the lymphocytes in the T cells and in the non-T cells. Now, if I go ahead and I prepare my samples, I record all of my controls in the system, then I go to unmix my experiment, I can get to that QC control section that we showed you earlier to generate the similarity matrix along with the complexity index at the bottom. So here's what came out for those two panels. The first thing you might notice is that for panel 2, there's quite a lot more darker pinks and reds in this panel compared to what's going on in panel 1. We can see visually there's going to be a lot more spillover here. And to capture that, the complexity index for panel 2 came out for 6.7 compared to 2.5 with the other set of 10 dyes used in panel 1. You can also get a grasp for this if you plot these dyes in the spectrum viewer and visually look how they're spread out over these different arrays. If I look at panel 1, you can see that the spectra for these 10 dyes are spread out pretty nicely throughout this emitted wavelength space. Compared to panel 2, it seems like every single one of the 10 dyes in the panel are right on top of each other in the same areas. There's a whole lot of photons showing up in the same space, and that's going to mean a lot of spillover for our panels. Then if you were to go to your multicolor data, you'll see some of these observations showing up when you plot things on the same scaling and take a look. So for example, here's some information with CD3 lymphocytes shown on the plot, and I'm showing CD56 on the x-axis and CD8 on the y, so you can look at your NK T cells. When I'm looking here, you can see visually the spread is different across the two panels, and the appearance of the population is a little different. These are some things that we're going to look to in deeper detail in the next slide. One question you might ask is, do you even have to run the full experiment to get a rough idea of what these indices look like? The answer is no. You can get a first stab at it by going to the Cytek Full Spectrum Viewer on our website. You can find it under our resources page, or you can go directly to the website link here. Once you're on the page, all you have to do is search and add the fluorochromes that you have in your panel to the list over here on the right. Then once you've added them, the tool will automatically generate these normalized MFI plots for you. So here again, I'm showing that panel 1 up top. And again, there's less overlap of the signatures here. It's going to be a lower complexity index result compared to panel 2 on the bottom. Next, when you're on the website, there's a button right above the plots that says Similarity Matrix. And if you click that, then you can generate those same similarity matrix tables that you saw in SpectroFlo 2.2 software, again with the complexity indices right underneath them. Next, if we compare the output from our online tool with what we were getting with our actual controls in the software, we'll see that they're not exactly the same, but roughly they give us something to start with that are pretty similar values. If I look at panel 1, the complexity with my simulated tool was 2.55 versus what I actually ran for the specific panel with my specific set of reagents gave me 2.5. And again for panel 2, the tool gave me a value of 6.15, and when I ran my actual reagents inside of SpectroFlo, I got around 6.7. Now, we've got all of our dyes chosen, our panels laid out, but how do we decide what the best reference control is for my panel? The best reference control is always going to be the control that has the spectrum that identically matches the spectrum of that fluorochrome in your multicolor tube. If those do not match, you'll see some interesting things happen in your data. So first, let's look at an example where the spectrum match up really nicely. From panel 1, here are 4 spectral overlays. Again, they're normalized. They're on a scale from 0 to 100%. And we have one control in green that was a single stained cells control. We also ran 3 different antibody capture beads. We're calling them bead 1, bead 2, and bead 3, and overlaid the spectra here for those as well. You can see that they're very, very similar. So if I go ahead and unmix my multicolor data with each of these different controls, how does the data look? Here I'm showing CD45 positive lymphocytes on each of the plots, and the plots are showing CD3 BV421 versus CD16 APC. The first plot here was unmixed using the cell control for BV421, and the next 3 are unmixed with each of the bead controls. All of them look very similar. They're well compensated. I don't see any errors in the unmixing. It looks really great. Now, let's look at a different example for BUV 805, where again we've created 4 single stained reference controls, one with the cells and one with each of our 3 different antibody capture beads. And you can see over here in the red, around R7, R8, there are some differences in the spectra over here. If I zoom in a little bit further, so I can see what's going on at these other smaller peaks in the spectra, there's actually quite a few differences in the spectra between these 4 different controls. Now what happens if I unmix my data using each of these controls with respect to BUV 805? Here's some data from the multicolor tube where I'm gating on CD3 positive lymphocytes. And again, I've unmixed my cell control in the first plot and then each of the beads in the later plot. And you can see there's clearly some unmixing errors where the compensation isn't quite right. And we can manually go in and correct these, but ideally you'd want to pick the reference control to unmix your data with whose spectra best matches what's going on the multicolor tube, so you don't have to waste your time making those corrections later. Another thing to pay attention to when you're unmixing your data is look at what's going on in the negatives, as if there are strange patterns here that can highlight unmixing errors in your data. So what I'm showing here, again from panel 1, we've unmixed the data and we've only used single stained controls made from that first bead, that first antibody capture bead. Then I gated the data on lymphocytes, and I'm plotting them here on these n by n plots, where I have CD4 across all of the x-axes. Then on each of the y-axes, I'm showing every single fluorochrome that's present in my panel. And what do you notice? You can see there's all these strange patterns where the negatives are duplicating. Sometimes even the positives are showing these duplicated patterns. So there's clearly a lot of errors in the unmixing of this data where the spectrum of the single stained control isn't matching what's going on the multicolor tube very well. Now, do you have to throw out and waste this data? No, you can correct for it and spend a lot of time manually going through and adjusting all of those errors. But again, it takes a lot of time and it takes a lot of understanding of the real biology of your cells. You don't introduce other errors by over or under correcting as well. And we want you to choose the best controls right off the bat so that you save time and don't have to go through that painful exercise. Now that you have all your controls picked out, how do you know if your panel is even any good to start with? Well, there's one thing that you should do the first time you run a panel, and that is to record single stain cells for each of your reagents and compare what's going on in your single stain cell tubes to what's happening in your multicolor sample. There's a lot that you can learn from this exercise, so let's walk through a few examples together that I've pulled from panel 1 as well as from panel 2. Here's CD56 Super Bright 600, and each of these histograms are showing lymphocytes. Now when I look at the single stain, I can compare what's going on in my negative in the single stain tube to what's going on in the negative in my multicolor tube. Are they broadening or are they staying the same? For this particular one, these green arrows are exactly the same size, and there's a slight broadening in the multicolor sample, but not much. And you can see the negative is shifted up a little bit compared to what's going on in the single stain cell tube. Another thing to pay attention to is how is the separation between my negative and positive in my single stained compared to my multicolor sample. Again, these blue lines are the exact same length, and you can see that since the negative has shifted up a little bit in the multicolor tube and the positive has shifted down a little bit, I can't pull them apart as much as I was able to in the single stain cells. That might be something I want to look into in my sample preparation. Another thing to pay attention to is where are my positives appearing in my single stain, and are they showing up at the same spot in my multicolor sample? If not, maybe I need to revisit my reagent titer or something else in my sample prep. Another example from panel 1 is the CD4 APC Cy7. If I do a similar comparison, again between the negatives, there's a slight broadening into the multicolor sample of that negative population when compared back to the single stain cells. But if I look at the separation of my negative and positive and where my positive peaks are appearing, those both look really great. That's a really great example of how everything is preserved from the single stain into the multicolor in that multicolor setting. Now here's a couple examples from panel 2. For CD56 BV785, you can see it doesn't look so great in the multicolor world. Back in the single stain cell space, I have this really nicely clustered negative population and really great separation of my negative and positive cells. But then when I go and look at what's going on in my multicolor sample, things look strange. My negatives are getting really broad, they've shifted, and it's much harder to gate between my CD56 positive and negative cells. And I probably won't be able to live with that in my panel. So for this particular reagent, I might want to consider moving CD56 to something else so that I can maintain this nice resolution that I was seeing in the single stain sample. One last one, here's CD4 BUV737. Again, if I compare the top single stain cells to the bottom multicolor sample, I do see a little broadening in the negatives, but I'm able to clearly differentiate my negative from my positive in the multicolor sample, and my positives are showing up at the same intensity as they were in the single stain. So this is one that I can live with. Another thing you'll want to do is once you've explored what's going on in your single stained world, is look at your overall panel when you've gated your data and see how things are looking. Can you live with the amount of spread that's in your panel? Are you able to gate on the cells of interest that you're going for? And if you happen to change something in your panel and rerun it, you can do a comparison like I'm doing here, where I compare my first panel to my second panel and make sure all of my bioexponential scales are identical across the two, so I can visually look for differences. For these two panels, I've highlighted just a few areas that caught our eye. One was on the CD15 expression that came up much nicer on the monocytes in panel 1 compared to panel 2. And again, if we look at that 56 versus 8 example, looking at the NKT cells, there's much less spread in panel 1 compared to panel 2's outcome for those same cells. And again, if we go further down, looking at the dendritic cells over in the CD123 versus 16 APC plot with the green arrows, the resolution came out stellar in panel 1, whereas panel 2, it's much harder to see what's going on. To continue diving into our data, now we're going to take the FCS files into FCS Express 7, and Sean is going to show us all of the cool news tools over there.
Great, thanks Janelle. So I did see we had a few questions that have come through during the webinar. Janelle is going to be taking a look at those while we talk about analyzing some of this data in FCS Express and some of the new tools here. So just hang tight with those questions, and we'll also make sure we come back around to any at the end that we didn't get to answer during the webinar. So again, what we're going to be looking at this portion of the webinar is using FCS Express 7 with Cytek spectral data files and some of the new tools in FCS Express. And we're going to be doing that through the context of the same data sets that Janelle had presented within panel 1 and panel 2, some of the multicolor versus single stain controls, as well as some of the other bead data sets that were shown. But in this section of the webinar, we're first going to cover some of the file formats that are necessary for loading data into FCS Express 7. We're going to be covering how to use spectral plots in FCS Express 7 at a high level, and then we're going to be diving into some of the panel-based data sets that Janelle had presented, looking at that in the context of some of the new tools in FCS Express that can help you perform some quality control on these data sets, as well as comparing the panels that you're creating from this type of analysis. So we're going to open up FCS Express 7 here to start having a look at a few things. And the first place that we're going to start is in a blank layout of FCS Express, and we're going to tell you a little bit about how to load data files into the software. So when you're working with data files that come from the Cytek instruments, they're going to look very much just like any standard FCS files that you may be familiar with. And what will happen is when you acquire any of your data sets, they'll generally be placed into two folders. One is going to be the raw folder for the raw unmixed data, and then the unmixed folder for the unmixed data files, which you'll be using within FCS Express. So what we can do is just navigate into locate our FCS file. Very simply, one way of getting data into FCS Express is dragging and dropping that into a layout in FCS Express. FCS Express is going to prompt you for what type of plot you'd like to insert for this data file. In this case, we will choose a density plot. And what you're going to see is a density plot has been inserted. We can move it, we can arrange it, just like we would do in objects like in PowerPoint. And very simply at a high level, if we need to create a gate, we can go into the gating tab and create some sort of gate on this data. So we'll call this gate cells, and you can move the gate around, of course, any way that you like, and all of your statistics will be updating in real time. Now, we're not going to cover all of the basics in FCS Express today, but what I do want to point out is that when you have acquired this data from the Cytek instrument, you also have access to the raw spectral data. We try and hide this in the background so that way you don't have to do anything except work with the standard FCS file if you want. But as long as you maintain your data folders in the raw and unmixed folders just as they came off of the instrument, what you'll be able to do in FCS Express is go into the Insert tab, and in the Other Plots section, you'll see a plot type here for Spectrum. And if you insert a spectrum plot for your data, you'll see that you have access to all of the cell-by-cell spectral data associated with this, including all of the individual lasers, as well as all of the lasers combined into one plot area. Now, if you have this data, you may be trying to figure out what this is. You need to make some sense of it. You may want to make it look a little bit nicer than it's come in here as default. So what you can do is you can right-click on a plot and choose Format, or you can double-click on that plot, and it's going to launch up a formatting dialog. And this is one of the new tools in FCS Express 7, is that these formatting dialogs kind of pop up off to the side of the page. And if you make a change in the formatting dialog, such as clicking Interpolate Values, it will make that change on the plot without having to open up multiple dialogs to do so. So just so we can get a little bit of understanding about how these spectral plots work in FCS Express and what these features do, is first we can interpolate values. And you can see that when we click Interpolate Values, essentially it's providing a smoothing for this plot, where we're connecting the kind of points between all of the individual detectors for all the individual cells. And Interpolate Values also kind of works in context here with resolution. So if I increase my resolution to 200, again, we can kind of get a finer gradient between all of the different spectral lines in here to help kind of beautify or make this plot easier to read. And you may wonder, why do we not check these boxes by default? The reason is because performing a lot of interpolation and changing the resolutions to very high values can be computationally intensive. So depending on what you need, you may want to just come in here and check these boxes to get started. Once you reach a certain point with interpolating and adding resolution, you reach a point of diminishing returns where we're going to be computing a lot of information, but your plots are not going to look much different. So, keep in mind you can turn these things on as you like. Additionally, when you have a spectral plot inserted, you can apply a gate to that spectral plot from any other plot. So if I want to apply the cells gate to the spectrum plot, we'll now be only viewing the spectrums from the cells that fall within this gate. And as you adjust this gate around the page, you're going to see that the spectrum plots are going to update in real time, so that way you'll be able to investigate further what's going on in these gated populations within the spectral plots. Now, additionally, with spectrum plots, there's a few different options that are available. If we go back to our specific options here, or let's look at our specific options for the spectral plot by clicking on it, you'll notice that instead of color on density, we also have an option for color on gated overlays. Now, what this will do is give you backgating information on your spectral plot from any of the gates that you've created. So any of the events that appear as red fall within the cells gate. Any of these events that appear as brown fall within this other gate that we've applied. And again, this backgating information will update immediately as you move these gates around. Now, the one final option is shade based on density. So if you'd like to get some sort of density information, kind of an average line of where these spectrum fall, you can enable that so you get information about backgating, you get information about the average line, and again, we're basing this off of all the events that are in the data set at the same time. But another very useful way of looking at this data is to look at average lines. So instead of looking at the spectrum across everything, we can choose the overlays category, and in the overlays to show, we can choose average. And by choosing average, we look at the average spectral line associated with this data set. And as we move our gates around the data set, we'll view how that average line changes. And if we apply a different gate, simply by dragging and dropping, you can see that the average line is going to change to reflect the gated population. Now, one other option that a lot of people tend to use in FCS Express is overlaying different gated populations on the same spectral plot. And we can accomplish this by taking a spectral plot and dragging another plot on top of it. Now, when we do so, we can choose Add the files to the plot as an overlay, and we'll see that we now have multiple overlays on this plot. Now, the new overlay that came in is displaying all spectrums, so we can go in and change that to average. And if we want this overlay to show the cells gate and the other overlay to show gate 1, what we'll now arrive at is an overlay of one gated population for another. So again, these tools are very quick and easy to set up in the software. And again, these are just some of the basic analysis tools for working with spectrum plots. But again, if you don't want to work with spectrum plots in FCS Express, you don't have to. And in fact, in the next portion of the webinar here, we're going to be discussing how to use panels and layouts in FCS Express to compare different data files, and we won't even be using spectral plots in a lot of ways. So to kind of shift gears here for a moment, we're going to close this layout, and we're going to take a look at a panel design in FCS Express. And again, this is recapitulating some of the data that Janelle had shown earlier. This is data from the panel 1 that she had shown, and you can see that we've built up a panel in FCS Express. We have a number of gates in the gating hierarchy. We have a spectral plot here where we're overlaying the CD3 positive over the CD3 negative populations, as well as a spectrum plot in the bottom. But again, these tools in FCS Express, these layouts that you create, can be used for quality control in a lot of different ways. So if we simply wanted to compare panel 1 to panel 2, one thing that we can do is utilize the data list, which we've docked over here on the right-hand side. And if we choose Add a Data File, instead of performing the drag and drop like we did before, we'll go and navigate to the Panel 2 data file and open it into the data list. So if we needed to perform some quick quality control to see what's going on across all of our gated populations and all of our parameters for these two different data files, there's no need to kind of recreate the wheel and recreate all these plots again. You can simply load them into the data list, and if we click on the second data file in the data list, you'll see that all of the data files in the plots update to now use panel 2. So the plots have updated, we're now displaying panel 2, and we can start seeing some of the differences here. For instance, CD4 versus CD8 and CD8 versus CD56. And by using these next and previous tools, by navigating between the data sets, it's a very convenient way of kind of comparing whatever type of data you need to look at. Additionally, in the Data tab, you're going to find buttons for next and previous that will allow you to jump between these. Now, as you become more familiar with the software and you need to perform batch processing, this doesn't just have to be for 1 or 2 data files. It can be for 200, for 2,000, and it can be done so in somewhat of an automated process to help generate results. But in FCS Express 7, we do have some new ways to help compare data, which I wanted to make you aware of today. So one of these is called a gate heat map. And you can see here that we've inserted what we call a gate heat map. And in this gate heat map, we're displaying the file name along the y-axis here. On the top x-axis, we're displaying all the gates that we've created in the gating hierarchy. And we're giving some sort of heat associated with these gated populations, which in this case is based off of the number of events per gate. Now, the way that we insert or access a gates heat map is through the Insert tab, Gates Heat Maps, and we can draw an object on the page just like we would draw an object in Microsoft PowerPoint. Now what you'll see is that the data file came in. It has some sort of statistic associated with the x-axis. So in this case, it came in as the first parameter, which is time. But if we wanted to look at the CD3 median or arithmetic mean, the MFI, across all of our gated populations, we can see that that is now laid out for us. But these gates heat maps can also be formatted to really hone in on what you need to look at and what you need to compare. So if I right-click on this gates heat map, I can go into my color levels. And one of the things that you'll find is that you can change your color scaling. So if I needed to kind of refine how my green to red gradient looks like, I can change the number of standard deviations that the gradient is based off of. I can also come in and choose different color gradients, so whatever might be easier for me to visualize this data with. Additionally, in FCS Express 7, we've added a color level for color blindness. So if you are affected by color blindness, we do have a color level for you to help navigate these gates heat maps. Please also keep in mind that the colorblind color level is associated with density plots and contour plots. So really, you can really see your data in a new way, especially if you're affected by color blindness. But again, the gradients are all here. You can pick and choose. Now additionally, you may not want to compare all gates. In the top plots here, you can see we've picked and choose a few gates. So in the gates to display section, you can pick and choose which gated populations you'd like to visualize in this array. FCS Express will pop them into the gates heat map, and you'll be able to work with these. Now, again, we're talking about in the context of comparing panels, so not just comparing gated populations within one sample. If we have multiple samples, you can compare them in an array-style map by dragging and dropping onto the gate heat map. We can say add it to the plot as a new overlay, and what you'll find is a new line for the new data file is going to be added, and you can do this for 1 data file, you can do this for 100 data files, and build up whatever type of array map you want. And very quickly, we can look at across all of our different gated populations, the number of events that are within gates. We can look at MFI values. In this case, it might be useful to look at spread between the different samples. So we've had some kind of minimal representation of the spread of CD3 by looking at the CVs. And very quickly and easily, we can see the differences that are starting to happen between these two different panels and the ways that they were acquired. So again, these are some new tools in the software to help you make comparisons between samples very quickly and easily. Now, another tool that we've added to FCS Express 7 is what we call what we call N-by-N plots. I know the folks at Cytek are very excited about these. I know that many of our customers are very excited about these as well. And what N-by-N plots allow you to do is when we have a panel set up or we have any sort of data file or plot inserted in FCS Express, we can highlight a plot and a multi-plot tab will become available. Now within the multi-plot tab, we can pick and choose to show histograms for every parameter. All parameters keeping the x-axis the same, all parameters keeping the y-axis the same, or use n by n plots to look at all parameters versus each other. Now the way that this works is when you click on n by n plots, it's going to prompt you for which parameters you may want to look at. So you may not want to look at everything, but you can pick and choose what you want to look at. And when we click OK, every combination of those parameters is going to be displayed in a matrix. We can adjust this matrix to fill out the page, to make it bigger, to make it smaller, however it is we want to visualize this. And very conveniently, these are grouped together. So if I'd like to apply a gate to every file, every display that's in here, I can choose to apply the gate. We are now looking at the lymphocytes across all of these different parameter combinations, and as we make changes to the gate, everything in the n by n plots is going to update for us immediately in real time, just like everything has been doing in FCS Express originally. Now additionally, n by n plots will take on whatever formatting the source plot has. So if this plot happened to be something like a contour plot, if it was a contour plot and we create n by n plots based off of that, what will happen is that all of your new plots that are created will be contour plots. So whatever kind of file format or whatever type of plot formatting you'd like to set up, you're going to use that and retain that through the n by n formatting. Now additionally, n by n plots are really great for QC tools as well. As Janelle showed earlier with unmixing, looking at beads versus cells, and comparing the spectrums and how the unmixing performed in all of those, we can do that over here. And what we've done in this case is we've set up a color dot plot. So with this n by n plot type, we're actually going to be backgating all the information for all of our different gated populations by choosing the color dot plot. Now that means if I want to change which gates are displayed in my color backgating, I can go into my gate list and I can say if I don't want to show CD8, I uncheck it. And you can see the orange gets removed from the plots or it gets added back in. Or if I want to show my 8s versus 56, right, you can add those in at any time. So again, in the context of looking at QC between cells versus beads and different unmixing strategies, you can see here that we've loaded in a file that was unmixed with cells, and in the plot that's highlighted in red, you can see that this data looks probably as you would expect. But as we use these tools in the data list to navigate between different data files, you can see that now when we're using comp beads, instead of using cells, we start to get some of these unmixing errors that Janelle had mentioned earlier. And again, by using these tools that are in the software, by using n by n plots, we can make very quick comparisons between many different strategies for unmixing, many different panels that we're looking at. There's a lot of different ways that you can use these n by n plots, but you can see they're very quick and efficient to set up in FCS Express, so you can get to this quality control data as quickly and easily as you would like. Now, another type of n by n plot that we have in FCS Express is called n by n histograms. What we're going to do is we're going to open up a new layout in FCS Express. So give me a moment while I open this up. But in this new layout in FCS Express, we're going to be looking at the differences between some of our multicolor controls and some of our single stain controls in the same context of what we were looking at with Janelle's data set that she had brought up earlier. So we're going to open up this example. It's going to load up in FCS Express. Again, it's going to be the same type of panel that we were looking at before and the same type of data. But in this case, we have a multicolor control. So this is the multicolor control from panel 1 that you're visualizing right now in this particular FCS Express layout. Now what we've done here is we've created n by n plots for histograms, and you can see that it will create n by n plots for as many different histogram combinations as you want. We also have a tool in the software called MultiParameter Overlays, so if we wanted to overlay all of our different parameters on top of each other to compare what's going on in the different parameters across however many parameters I have in my data set, we can quickly and easily create that. So what we're going to show you in the next 5 minutes here is essentially how to create these plots. So if you're working with these n by n plots for histograms, I'm going to put these off to the side and we'll show you how to get these created. Again, you can select any source plot you want. In this case, the formatting does not matter because we're going to convert this plot over to histograms. So again, we'll click on the n by n plots for histograms, we'll clear the selection, and we'll choose, again, the same kind of parameters that we had selected before, CD3, CD56, CD14, CD16, CD4, and you're going to see that we'll now arrive at our n by n plots as grouped into histograms. And again, with these histogram plots, if I need to apply a gate, I can apply my cells gate, and you'll notice that as I move this cells gate, everything within those plots is going to update for us. So you can really visualize all of the different markers that are included within this multicolor control. So with that, I'm going to pull my original plot back over here. Again, I think those are pretty easy to create, and you get the idea of what we're trying to do there. But another plot type that's very useful and that's new in FCS Express 7 is these multi-parameter overlays. So the way that multi-parameter overlays get created in FCS Express is when we have a histogram inserted. We'll pop one of these in here to the software, and we'll change to CD15 and make sure that we have an appropriate gate applied. Is if you right-click on the histogram, you'll be prompted to add parameter overlays. Now, what will happen is when I choose to add parameter overlays, I can go in and I can pick and choose which parameters I want to overlay in this plot. So if I wanted to choose all the ones that I had highlighted over here on the left, I'm going to grab CD14. What will happen is when I create this, you see that all of the parameters that are associated with the ones that I chose that are associated with this data file will now be overlaid. But again, in FCS Express, you can format these plots to look like whatever it is that you'd like. So if I wanted to beautify these a little bit, I can right-click and choose Format. And what a lot of people like to do with these stacked overlays is add a fill, add some sort of transparency. A lot of times people like to smooth these plots a little bit. And again, you can see that these changes are reflected in real time within FCS Express. So again, it becomes very quick and very easy to look at what's going on between these different parameters very, very simply. Now, again, in this data set, we have single-stained controls. So how can we utilize them to compare against everything else? Well, again, we can go into our data list, and if we click on the CD3 control, all of the plots, all of our multi-parameter overlays are going to update, and you can see we're highlighting the CD3. If we click on CD4, we're going to be coming in and highlighting the CD4 in our n by n plots, so on and so forth through whatever type of plots it is that we want to look at here. Now, an additional useful feature is that at some points your gated populations may have to be different between some of your different controls and some of the different samples that you're looking at. So in version 6 of FCS Express, we introduced data-specific gates, and what these do is they make a gate specific to a control or a data file. And in version 6, you had to select the gate and click on data-specific gate. But in version 7, if I hold down the Shift key and I start adjusting that gate, it will actually make that gate data file specific automatically. So this new keyboard shortcut that we've added really simplifies creating these data-specific gates. And you can see that as I move through the different controls that these gating positions are maintained and they're retained and remembered all the time. Now, one other thing I wanted to show you is I know we have many different controls associated in this data set, and it would be really useful if we could visualize all of these side by side. So one thing you can do is if you have n by n plots created in your analysis, whatever type, or really whatever type of plot you want to do this for, you can click on the Home tab, Multiple, Duplicate, and Next when you have the plot selected, and you can choose to essentially create new plots based on these plots for everything that's in your data list. So I'm going to ask FCS Express to duplicate this plot, this n by n plot, for all of the different controls that I have on my data list. And what FCS Express is doing right now is it's loading that data in, and again, these are very big data files. It's opening them up into new n by n plots, and it's going to be plotting these on new pages as they're drawn in the software. So in just a second or two here, we're going to see that we're going to have additional pages, pages 2, 3, 4, 5, and on each of these pages, we're going to be having n by n plots for all of our individual controls. So on this page, page 1, we have our multicolor control. Page 2, we're looking at our CD3s, our CD356. Page 3, you can see we're looking at our CD4s, so on and so forth. So again, using these tools for the n by n plots and using multiple duplicate and next is a great way to compare many different controls side by side while still looking at all of the different parameters associated with them. Now, the last thing I wanted to leave you with to show you about how to use some of the overlays and tools that you can use in FCS Express for looking at controls is to simply show you how to overlay samples on a histogram. So you can see in this histogram, we're looking at the multicolor control or the multicolor sample, and we're looking at CD4. So if you didn't want to look at every parameter, maybe CD4 was the most interesting or the most troublesome that you wanted to look at, you could simply grab that control for the single stain from our data list, drag it and drop it onto the histogram, and add it as a new overlay. Now what you're going to see is the new overlay is going to appear in red. And again, if we want to right-click and use some of the new formatting tools in FCS Express, we can come in here, grab these overlays, make sure that we smooth them the same way, make sure we fill them, make sure we give them some sort of transparency, and we can see very quickly and easily the differences between our single stain control, which is in red. We can see there's probably a much lower CV for the negatives as opposed to our multicolor sample that we've acquired here. So again, there's a lot of good tools in FCS Express, especially now in FCS Express 7, to help you perform these comparisons, which hopefully will allow you to arrive at some better data, arrive at some better quality controls. So with that, I wanted to summarize in that FCS Express 7 really allows you easy access to the raw spectral data. It doesn't mean that you have to use it all the time. It doesn't mean that you have to use a spectral plot. But if you need it, you can access it. You can work with any of the new formatting tools in the software to get that spectral plot to look like what you need and how you like to view it. And again, you can format those so they're specific to your experiment, or they meet specific publication requirements. And integrating the spectrum plots with new tools in FCS Express can help make analysis even more efficient. And that also goes for integrating any of your quality control type of tools that you might be used to using in SpectroFlo. You can take a lot of what you've learned there. You can create some panels, some layouts in FCS Express to help you easily compare side by side. And you can do that for many different data files. You can do that in a batch process. You can do that with multicolor controls versus single stain. You can do that for cells versus beads. Really, in the end, it's up to you, whatever it is you may want to look at there. So with that, I wanted to say thank you for attending the webinar, and thank you for hopefully joining us to learn a little bit more about some of the new tools in SpectroFlo v2.2 software, learning about some of the new tools in FCS Express 7, and also how a lot of these tools in this collaboration that Cytek and Novo software have help bring some efficiency and hopefully better data and better quality to your data sets. I also wanted to say thank you to Janelle for presenting on the webinar today, and a thank you in general to Cytek and all of our joint customers for joining us today. So thank you very much for joining the webinar, and we're going to be stopping to take some questions in just a few moments.